So back in 2018, some researchers over at Google dropped a paper that honestly changed everything for AI. And no, it wasn't about flashy stuff like self-driving cars. This was about something way more fundamental, something deeply human, teaching a machine how to actually understand the words we use. Today, we're going to tear down that paper and get to know its creation, a little thing called BERT.
All right, so here's the game plan. We're going to start with why language is such a puzzle for computers in the first place. Then we'll look at the old way of doing things, the one-way street approach. After that, we'll get into the main event, BERT, the game changer. We'll see how they trained it with a couple of really clever tricks, check out the mind-blowing results, and finally, talk about why it's still such a big deal today.
All right, Section 1, the language puzzle. So first things first, why is it so ridiculously hard for a computer to get what we're saying? Well, it all boils down to one super important and super tricky little word, context.
I mean, think about it. For you and me, it's second nature. But how can a computer truly understand a sentence? A word isn't just a dictionary definition, right? Its meaning gets colored in by all the other words surrounding it. It's all about the company it keeps. So the real question is, how on earth do you program that kind of intuition? Okay, this is the perfect example. Look at these two sentences. The bank of the river was steep versus I need to go to the bank to deposit a check. The word bank is the same in both, right? But it means something completely different. One's a place for money, the other is the side of a river. And how do you know which is which? You have to see the entire sentence. You need the words before and after. That right there, that was the big puzzle that needed solving.
So before BERT came along, even the smartest language models had this huge blind spot. You could say they were all stuck reading on a one-way street.
And these were called unidirectional models. It's exactly what it sounds like. They only read in one direction, usually left to right. Think about it. It's like you're reading a sentence, and you can only ever see the words you've already passed. You have no clue what's coming next. So, yeah, you can guess the next word, but your understanding of the words you've just read is incomplete, because you're missing half the context. And don't just take my word for it. The creators of BERT said it themselves, right in the paper. They called this one-way street approach a major limitation. They basically said, look, this is holding us back. It's just not good enough for tasks where you need to understand the whole picture.
This visual just nails the difference. On the left, you've got the old school models, like OpenAI's GPT. See how each word can only look backwards? It's blind to what's coming up. But now, look at the right. That's BERT. Every single word can look at every other word in the sentence, forwards and backwards, all at the same time. It's not a one-way street anymore. It's a superhighway of information.
And this is where our hero, BERT, enters the scene. This was the game-changing idea, a two-way street for language. It's this incredibly simple yet powerful thought. Hey, if we humans need the full picture to get it, maybe computers do too.
So this was the big what-if moment. What if a model didn't have to follow the rules? What if it could just, look at the whole sentence all at once, reading it from the beginning to the end and the end to the beginning at the exact same time?
And that's BERT. That's exactly what it does. The name actually tells you the whole story. Bidirectional Encoder Representations from Transformers. The only word you really need to remember there is that first one, bidirectional. It was built from the ground up with one goal in mind, to see everything, left and right, at every level.
Okay, so how did they actually do it? I mean, this is where the magic happens. You can't just show the model the whole sentence and say, predict the next word, right? That's like giving someone the answers to a test during the test. It's cheating. So the researchers had to get creative. They came up with two really clever training games.
And these two tasks are pretty much the secret sauce. First, something called the Masked Language Model, or MLM for short. And second, Next Sentence Prediction, or NSP. Let's dig into what those actually mean.
So the Masked Language Model is honestly just brilliant. Imagine a fill-in-the-blanks quiz. You take a sentence like, my dog is hairy, and you just block out one of the words. The AI's job is to figure out what that hidden word is, using all the other words around it as clues. By doing this millions of times, it forces the model to learn deep relationships between words. It's awesome.
The second game is all about understanding how sentences connect to each other. You give the model two sentences, and you ask it a simple question. Does the second sentence logically follow the first one? So, for example, the man went to the store, followed by, he bought a gallon of milk. That makes sense, right? That's an is next. But the man went to the store, followed by, penguins are flightless birds. No, that's a not next. This simple game taught BERT to understand conversation flow and logic.
All right, so the training method was super clever, but this is the moment of truth. Did it actually work? Well, they put BERT to the test on a whole bunch of language challenges, and the results, oh man, they were just stunning.
Get this. On 11 different standard tests for understanding language, 11, BERT didn't just do a little bit better than the old models. It absolutely smashed the records. It set a new state-of-the-art across the board. It was a total domination.
So let's put some numbers to it. Take the GLUE benchmark. That's kind of like the decathlon for language models, a bunch of different tasks rolled into one score. The previous champ, OpenAI's GPT, was at 72.8. BERT comes along and scores an 80.5. Now, a 7-point jump might not sound like much, but in this field, that's not a step forward. That is a giant leap. It's huge.
Okay, but this one might be even crazier. Squad is a question answering test. Before BERT, the top systems were these massive, complicated things called ensembles. Basically, you'd tape a bunch of different models together hoping for a better score, and their best was 91.7. Then comes a single BERT model, all by itself, and it scores 93.2. It proves that a smarter design is way better than just throwing more complexity at the problem.
So, why does all this matter? Why are we still talking about a paper from 2018? Because BERT wasn't just another small step forward. It was a complete shift in how we thought about teaching computers to understand language. Its ripple effects are, well, everywhere in AI today.
If you remember just 3 things from all this, make it these. 1. BERT proved that looking at language from both directions isn't just a nice to have, it's absolutely crucial. 2. It kick-started the era of pre-training. Instead of building a new model for every little task, you could start with a powerful base like BERT and just fine-tune it. This saved a ton of work. And 3, well, the results speak for themselves. It just blew the doors off what we thought was possible.
You know, BERT was really the thing that taught machines to read between the lines, to truly get context. It's the foundation that so much of the incredible AI we see today is built on. It learned context. So it leaves you wondering, right? What's the next big, deeply human thing we're going to teach AI to understand? What's the next BERT?